Good morning everyone. I am Surya Lokesh, Chemical Engineering Department, VNIT Nagpur. Today we will be discussing about the topic rotational motion. Actually, the rotational motion is directly related with the term system of particles. Now, what is system of particles? A system of particles is nothing but the group of particles, that is group of point masses which are located at some distance in between them. So, if you consider a system of particles, that is a group of particles, the distance between the particles should be the same. That is, if a force is applied onto this system of particles, the force is applied to each and every individual particle in the system. Then all these particles will be moving along with each other, and the distance between them will remain same. That can be termed as system of particles. For example, if you take a car. Here the engine, the person inside the car and the wheels, everything is included in the system. That entire thing is a system. Now if a force is applied onto this car, the car moves in one direction. That is, all the particles inside the car are moving in the same direction. So this is an example of system of particles. Now in the system of particles, that is, bodies can be divided into two types, that is rigid body and flexible body. Rigid and flexible. So in rigid body, if you consider a rigid body, if a force is applied at this point, this particle may move with some velocity and it covers some displacement, and you can observe that this point is also moving with the same velocity and the same distance is covered. That is, there is no difference in between these 2 points. That is, the difference is the distance is the same. So this is a rigid body. Now for example, a flexible body is, if you consider this thing, if I apply a force here, only this point is moving and this point does not have any displacement. So this can be termed as flexible body. Now for the bodies, now we will discuss about the types of motions. For a point mass, there will be a linear motion, and the other is a circular motion and an oscillatory motion. These three are the motions for the point mass. And for rigid body will be having two types of motion, that is translatory motion and rotational motion. The translatory motion is nothing but all the particles will be moving in parallel direction and with the same distance in between them. So all the particles will be moving in the same direction, that is in parallel direction. So this is a translatory motion. And the second is rotational motion. Now if you consider this object, so if I am rotating this object in this direction in 360 degrees, so you can observe that all these points, this point, this point and this point, are in circular motion. Now if you keenly observe, this point is moving in a smaller circle and this point is moving in a larger circle. That is, this point is covering a smaller distance in the same time in which this point is covering a larger distance. So you can say that the linear velocity of this point and this point is different, but you can also observe that the amount of angle covered by the 2 points is same. If you consider the rotation of this, if the complete rotation of this object is considered, this point is covering 360 degrees in the same time as in which this point is covering the 360 degrees. That is, the angular velocity is same. So you can say that a body is in rotational motion when all the particles of the body is moving with the same angular velocity. Now point of rotation. So if you consider circular plate and it is rotating. So this point is moving in this circle and this point is moving in this circle. So here all the points on the circular plate are moving in a rigid circles with some radius, with different radius, but the center is the same. So this can be termed as center of rotation. For every rotation there will be a point which is termed as center of rotation, around which all the points will be moving in the circular direction. Now axis of rotation. So if you consider a globe which is rotating, so you consider this as a globe. This is rotating in this direction. So this point will be moving in this circle, and this point will be moving in this circle. So you can observe that there are different center of rotation for each and every point. So you can keenly observe that clearly observe that all this center of rotation will be along the same line. This is nothing but the axis of rotation. This is nothing but the axis of rotation. Now, and after that, after the axis of rotation, that is plane of rotation. The plane of rotation is nothing but it is normal to the axis of rotation. That is, if you consider this object, so let this be the x-axis, and we are rotating this object in this direction. This axis of rotation is x-axis, but the plane of rotation is, it is covering y direction, and now it is going in z direction. So you can clearly observe that this is moving in yz direction. That is, the plane of rotation of this object is yz plane, and x is the axis of rotation. So you can understand what is the plane of rotation. It is the normal plane to the axis of rotation. That is, here if you consider the x-axis as the axis of rotation, the yz plane is the plane of rotation. Now, this sense of rotation. Actually, in physics we will take the clockwise rotation as a negative, and anti-clockwise as positive. This is nothing but just a convention. This clockwise is termed as negative, and the anti-clockwise is termed as positive. Now the next one is moment. Moment is nothing but the force of effect of rotational motion. Now let us consider this is a door, and this is hinged at this point. Now if you try to open this door by applying a force here, and you also try to open this door by applying a force here, both are different cases, because here the force applied will be less than the force applied at this point, because of the moment of the force. Here the moment of force is more, hence the rotation is easy. But here, because of the less radius of rotation, the moment of force is very less, that it becomes very difficult to move this door. Hence the moment is nothing but the effect of rotational motion. Thank you.